All right, cool. So we are recording now. Happy Tuesday, everyone. It is May 12th. We are down to our final few weeks. I'm going to go through the announcements for the first 5 to 10 minutes here because there's a lot of new important information that might relate to you. Some of the stuff that you see there, numbers 1 through 3, are basically repetitions of old information. Sorry, my dog is eating paper right now, so I'm trying to stop her. Repetition of old information. A lot of these old stuff, the remote learning agenda, the RLQs, we've talked about those many times over. Remote learning agenda is this thing. I actually made some adjustments to it this week. You notice down here towards the bottom, there, Kaya, stop it. There's no more final mentioned on there at all. We'll talk about why that is in a little bit. And also you notice the last week of May, 5/26 and 5/28, I've designated now as a review. More to come on that in a second. The RLQs are these beloved things right here. I already got one question on it today. So if you ever have questions, y'all know that you could ask those. They're typically posted continuously on the post I put up on the Google Classroom. So like the link that y'all use to get here, the RLQ is on there. Feel free to ask me those questions there and or email me. I know email seems to be the preferred method, so keep doing that too. Just wanted to make sure, bring the attention that it is there. Cool. Ed puzzles and assignments. This is a subtly different piece of information. I have adjusted the due dates. So basically everything besides one assignment is due by 5/22. So technically number 2, Ed puzzles and assignments due by 5/22 isn't 100% correct because our last lesson, lesson 25, I think if I check the RLA right now, is due by the 25th. Yeah, so you see lesson 25 right here, due by 5/25. Everything else, every other assignment in Edpuzzle is due by the 22nd. Now that adjustment and that update has been made to kind of work with what you might have heard in some of your other classes as a flexible finish line. So really trying to get all of our work in by the 22nd, which is next Friday. Stop, Kaya. I'm sorry, my dog is literally eating like everything on the bed right now. So everything is due by the 22nd to really try to focus on getting our grades where we want to be for the last week or so of school. More to come on that when we get to the red piece of information down there. Did y'all have a question? Someone have a question right now?
Grandma.
Okay. Cool. Office hours, Zoom sessions, Fridays at 10. Some of you have been joining. If you feel like you wanted to stop in and say hey or join the sessions, come in on Friday at 10 a.m. Sweet. So the new pieces of information, the main reason I really wanted to get as many people on here today as possible was to talk about the texts that are in red, the FAQs and info sheet. So I'm going to jump to that right now. So I posted yesterday and today, I think it's in the information, a little bit of FAQs, frequently asked questions, and some answers to them. Obviously, if you're here right now, you know when the Zoom sessions are, so you don't really need to pay attention to this top one because you're here. Most of you that are here, and a lot of y'all, even if you're not here, if you're watching this on YouTube, you already answered the second question: how do I submit work, take pictures, put them on there? But this is a consolidated way of giving you that information. Now, the real important stuff is where I'm kind of zooming in right now. How are grades going to look? So this is the same in basically all of your classes. So the updated grading scale for your classes this year are as follows. If you're earning an A, you get an A. If you have a B in the class, you get a B. If you have a C in the class, you get a C. If you currently have a D in the class, or you finish with what we would typically call a D in the class, that will be now classified as credit. And if you have an F in this class, and very few of you do, that would be a no credit situation. My goal is to have every single person be above that no credit line. Basically, I don't want to fail anyone. So hopefully, if you were in that F range, I've reached out to either you and or your parent, and we're working to getting that up and running. So I know some of you were in that range, and I've been getting work in from y'all, and that's great. So we're getting closer and closer to having no fails, which is the optimum goal. So keep working hard. Here's a big one, y'all. Will there be a final? Okay. The answer to that question is now no. We have been kind of moving back and forth with that information throughout the remote learning situation over the last few months. Originally, it was nope, definitely no final in terms of a test, but I'm going to give you a project. Now, here's the update to that. I'm going to provide you an optional project there, okay? So that's the key word for those who want the opportunity to boost their grade up. We're going to talk a little bit more about that in just 1 second when I show you another Google form. But effectively, if you want the opportunity to get your grade up, you should make sure you do all of your homework, the Edpuzzles, and then do the optional project as well. More to come on that optional project in the near future. So optional project is going to be due by May 29th. You can see this on row 7. When is all work due? Obviously, you're in Algebra 1. So other than the optional project, everything is due by May 25th. That's like the absolute last date. If you want the optional project, it is going to be due by 2 weeks from this Friday, May 29th. Okay, that's kind of the flexible date there. Last but not least, if you're on that cusp, if you have a C or a C plus and you're trying to get up to a B minus, how can you get your grade up in any scenario? If you're at the cusp of failing and you want to get a D, if you are cusp of a B and you want to get to an A, or really just try to boost your grade in any capacity, complete your assignments first, then do the Edpuzzles, and then the optional project will be available too, okay? So the optional project is not currently put up on the Google Classroom. I will do that. I will post that next Friday, and we will have some conversation next week specifically about it. All right, before I move forward and back to the slideshow, does anyone have any questions about anything in front of you? If you do, unmute yourself and let me know, or type it in the chat box.
Is the project that you're signing I know it's a replacement for the final and it can be boosted up. Is it like boost up your grade? But is it like I lost my question. It's this coronavirus thing. I'm sorry.
Yeah, you're really modulated. You're breaking up a lot, Zaid. But let me see if I can answer that question from what I heard. Okay.
I have McDonald's Wi-Fi.
Yeah, fair enough. Yeah, that's probably what's doing it then. So let me try to answer your question as best as I can, and then let me know if you have another question after I answer it. Okay. So basically, the optional project is an opportunity for you to show me what you know about quadratics, all the work that we've been doing so far. And it is optional in the sense that it can boost your grade up. Now, if you do the optional project and you do terribly on it and it would bring your grade down, I'm just not going to count it. Okay. So the optional project only has the capacity or the opportunity to bring your grade up. If you turn in a bad project and you get an F on it and it would bring your grade down, I just basically won't put it into the grade book. Now, if you're already cool with your grade, and some of you I've reached out to individually. So if you got an email from me already, then that's what you need to go off of, okay? But if you haven't received an email from me, specifically regarding moving forward, and you're cool. Let's say you have a 75 and you're like, you know what? A C in Algebra 1 is better than I thought I was going to do. I'm not good at math, or I don't like math. I'm cool with a C. Then you don't have to do the optional project. But if you are at like a 78, 79, and you want to try to get that up to a B minus to try to boost that grade up, the optional project is a great way to help you do that. Does that make sense?
Yeah.
Right on, man.
That's basically what I'm trying to say.
Cool. Yeah, so the optional project is really there just to try to give you an opportunity to help you move your grade up if you want to do so, okay? And I'm going to obviously do it in a way that involves a high level of math because that's what class that we're in, but I really want to give you the opportunity if you're so inclined. Does anyone other than Zaid have a question regarding any of the information we've talked about so far? Because if not, I'm going to move into a form that I'm going to post right after this session that y'all can fill out. Cool. All right, so what I'm going to post right after this session is basically another Google form. It looks a little something like this. It's going to be called the Remote Learning Year End. Notice when right underneath that title, it says check your Infinite Campus before filling this out. So I want every single one of y'all to fill this out just to let me know where you're at, if you're comfortable with your grade, and what I can do to help you. So here's the required information: your last name, your first name, your email. Okay, that way I can collect the data efficiently. And here's the most important question. Based on your grade in Infinite Campus, your current grade in this class, choose the option that best suits your desires. Meaning, if you look at Infinite Campus and you're satisfied with your grade and you're not interested in bringing it up, then you can click this first option that says, I'm satisfied with my grade as it is, I'm not interested in raising my score, and do not want a project. If you have a C, you're cool with a C, boom, you can click that one. If you have a B- or a B and you're cool with it, boom. So if you are, on the other hand, you want that project that we've kind of been talking about, click that bottom button and say, I want to boost my score, AKA my grade. So that might've been a better thing to write in there. I want to boost my grade, give me the projects to help me raise it up. Also, there's a couple of other questions down here. If you want to boost your grade, are you willing to join Zoom sessions? Obviously, the 15 of you that are here right now, the answer to that is yes, because you've been joining. So I'm commending y'all for that. And if you have any comments or concerns or questions as it relates to your grade, that's what that bottom section is for. It's not mandatory, but you could type something in there for me to look at. So this is not currently accessible for y'all. I'm going to post it right after this session, but this is where you can let me know if you want the project or anything else that I could do to help you, all right? And keep in mind, the project doesn't guarantee it'll boost your grade up, but it is an opportunity for you to boost your grade up. So any other questions regarding this form that will be posted this afternoon right after this session? Sweet, okay, cool. I think we're getting it then. We're pretty much cruising through this. I know it's been a lot of information just on announcements for like the first 15 minutes, but I really wanted to get this info out because we're down to the last few weeks. As you can see at the bottom of the screen, T-3 weeks, we're almost there. So that takes us to number 6, optional final project. I've said it about 20 times now. Again, it is optional. Let me know if you want it. We'll talk more about it next Thursday. All right, then, without any further ado, assuming we have no questions because the questions have been asked, let's get to our lesson today, which is on lesson 17. We are revisiting the zero product property. That was what we did on lesson 11, that idea of setting parentheses equal to 0 and solving. And we're revisiting it now to kind of culminate all the work that we've done over the last month when it means solving more difficult equations, factoring difficult polynomials, and then what we'll do on Thursday and next Tuesday is put a cherry on top and be like, oh, wow, we can combine what it means to factor, what it means to use a zero product property to solve, and solve quadratic equations efficiently and accurately. And what we're going to do today is, since this is a revisit or a review of this property, we're actually going to do the assignment together. So if you have your text in front of you, or if you have a blank piece of paper, we're going to turn it to page 592, and we're going to start on numbers 2, 3, 5, and 7. So let's get this party started. Page 592, numbers 2, 3, 5, and 7. I don't know why. Whoa, my numbers were off. We're not doing 592. We're starting on 599. My numbers were a little off. I think that 592 was a non-homework problem, but I decided to transition into just doing the homework. So sorry about that. Turn it to page 599. We're going to do numbers 1, 2, and 3 first. All right. So now that we're all on page 599, again, this is in lesson 17. We're going to use the zero product property to our advantage to help us solve equations. And hopefully on page 599, stuff like problem number 1 looks somewhat familiar to you. And if you're comfortable with it, can anyone tell me what we would do to solve this problem? Because notice that's what we're trying to do here. You could unmute yourself. You could type it in the chat box if you're comfortable. How could I solve this problem? Or how many solutions are there going to be? Those are 2 good questions. Anyone think they know? Silent, silent. Let's start off with the first one. Actually, the second question. How many solutions are there going to be? Anyone can take a guess on that? Yeah, Caitlin, great call. 2 of them, no doubt. There's going to be 2 solutions, and here's how she knows that. There's 1 parenthesis and a whole second parenthesis. So This is called the zero product property because we have a product, which means we have a multiplication problem. We have a multiplication problem whose answer is 0. And that's exactly what's happening here. We have the green parenthesis, notice no operation sign between those parentheses, times the orange parenthesis. So how do we solve multiplication problems? Green times orange that equals 0. We do exactly what Ashley just said. Oh, sorry, Ashley, you said that privately, but you were 100% correct that we set them equal to 0. So my bad. But yeah, you were right. We take each parenthesis and we set them equal to 0. Great call. So Francis, you went about distributing, which is awesome. That's a good job, man. But in this case, that would actually make it a little bit more difficult to solve because Francis, what we'll learn on Thursday is that we would take your answer, work to get it in this situation, so then we could do what was just recommended by setting each factor equal to 0. So basically, this is the factored form of what Francis has written down, and he did a great job distributing. But now we're just going to take each parenthesis and set them equal to 0 to solve. So now working with the green one, we work backwards and use opposites. We add 1 to both sides, effectively getting rid of the -1 on the left. And getting 2x is equal to 1, we would divide both sides by 2, allowing us to isolate x for our first solution that x is equal to 1/2. And then we would take our second parenthesis, which we see here in orange, we would subtract 3 from both sides, and we would get just an x now by itself equals to 0 minus 3 or -3. And how many solutions did Caitlin say we would have? 2, and sure enough, we have 2 solutions, 1/2 and -3, it checks out. So the zero product property is just a way where we use multiplication whose answer is equal to 0, and we set the factors, the things that are being multiplied, the parentheses, equal to 0 and solve. Okay. Then on that logic, how many answers are we going to have here on number 2? Great call, Francis. We're going to have 3 separate answers, and here's why. Because we have 1, 2, 3 separate factors, and I'm specifically using those words because these are all factors. Factor number 1, t minus 4, factor number 2, 3t plus 1, factor number 3, t plus 2. Factors are things that are multiplying by each other, and sure enough, here in problem number 2, we have 3 factors, so what we could do is set each factor, like t minus 4, individually equal to 0. So this is, again, straight up a flashback to lesson 11, where we learned different ways to solve seemingly difficult equations. But again, I use that word seemingly because we're really just saying, oh, are these things multiplying? Yep. If you ever have a multiplication problem that's equal to 0, just take the factors, in this case the parentheses, and set them all equal to 0. Well, now 2 of these are really easy to solve. Get rid of subtraction with addition. I'm working with the red one first. We get t now by itself being equal to 4. Solution. We get, I'm going to work with the blue one because it's second easiest to solve. Get rid of addition with subtraction. Subtract 2 from both sides. T is now by itself, and it's equal to 0 minus 2 or -2. Second solution. And our third and final potential solution is going to be solved by using SADMATH, getting rid of addition first via subtraction. It's opposite, leaving us with just a 3t, now being equal to -1. And then getting rid of that multiplication with division, t is equal to -1/3. And let me try to write that a little bit cleaner for y'all. You could also turn that into a decimal at -0.3 repeating as well. But long story short is we had 1 factor, 2 factors, 3 factors that we then set the factors equal to 0. So basically all the work that we have done in this last month has been figuring out how to get factors by using that X chart and GCFs. And now we're trending in towards using that skill that we've perfected over the last 2 to 3 weeks, factoring to set the factors equal to 0 by using what we call the zero product property. It's like now basically combining all that information from lessons 11, 14, and 15 all into one Mondo lesson that will really put the cherry on top with on Thursday. All right, we've done numbers 1 and 2. Number 3 is our next behemoth that we got to work with. I'm not going to tell you how to do this one right from the jump. Does anyone know how we could solve number 3? There's a few ways. There's actually many tactics. So it's more a matter of preference or trial and error. Does anyone have a recommendation? Get X by itself? I like that answer. Great call, Ashley. Yeah, we can get X by itself. Either Ashley or anyone else, can you double down and basically tell me how we could do that? Because I agree. If we can do what Ashley just said and get X by itself, we have our solution, no doubt. Good call, Francis. X is going to equal 3. How'd you get that, man? Awesome. Looks like Francis and Ashley are doubling down and saying, all right, SADMAP, we can get rid of subtraction with addition still. That doesn't change. And when we do so, what we now have is x is equal x squared. Notice that big squared there. X squared hasn't gone away yet. It's still equal to 9 through the addition of 9 to both sides. Right on. Now, the big question is this. X is not by itself. It's being squared. How do we get rid of that? Francis just told us. To get rid of a square, we use its opposite, and we learned last module with all those parent functions, that major operation, the thing that undoes the square is the square root. So Ashley and Francis square rooted after adding 9, they square rooted both sides. When you square root a square, you're just left with an x. And when you square root 9, you're left with one of the answers Francis gave us. But I'm going to make one last claim that technically the square root of 9 could be 3, but the square root of 9 could also equal something else. Does anyone else know what that could be? There's one other answer here. And by the way, here's a big hint, everyone. When you have an exponent, it tells you the possible number of solutions. So since our exponent up here is 2, we should potentially have 2 solutions down here. And right now we only have one solution, that's 3. Does anyone think they know what the other solution might be? Close, Ashley. It's not -9, but it is a negative. There you go, -3. Because a square root is basically saying what number times itself, or think about a square. If you have a square that has an area of 9, theoretically you could have dimensions of 3 times 3, check. Or if you have an area that looks more like a rectangle, but you kind of get the idea. If you have an area that's 9, it could also be -3 times -3. So the square root of 9 is both positive and -3. We have a power of 2, so we have 2 solutions. Now, what Ashley and Francis did there to solve that problem is they used SADMAP. They worked backwards. Used opposites. They got rid of subtraction first with addition. There was no addition. There was no division. There was no multiplication. They got rid of the exponent by using opposites, which was square root. And there's number 3. Okay, that brings us to number 6. Number 6 is the best and arguably the hardest problem on this page. And I say it's the best because it takes a strong skill of where we've been during the last month. How in the world can we solve this? And I'll give you a hint. There's going to be 2 solutions. Notice that highest exponent tells you the number of solutions. So x is going to equal 2 things. We'll figure out what that is in just a second. But how could I do so? Any thoughts? And this is kind of a bold one. If you're going to answer this problem, I commend you because this is a hard problem. You've never solved anything like this yet. Not once, unless you've been doing math on your own without me knowing about it, in which case, more power to you. But we're going to get 2 answers here. X is going to be something and something else. And I know that we're going to get 2 answers because fundamental theorem of algebra says, boom, take that squared. Okay, I got it. Someone gave me an answer, and I like the logic here that said combine like terms. However, do we have any like terms here? Unfortunately, we do not have a like terms because these 2 things are very different. And the reason why they're different is because one has an exponent and one does not, right there. There's no exponent right there. So unfortunately, we can't combine the like terms. It doesn't work out that way, but I like the idea because that would have worked. If it would have been this, definitely we could have combined like terms. But unfortunately, that's not a 2 in front, that's a power. But I like the logic. It's a good idea. Doesn't work though. So any other thoughts? You can shoot them out. I don't honestly, I love to hear what y'all think, because when I was first doing this too, I wouldn't have been able to get this right off the bat. I would have had it been taught. So I'm asking you a tough question, really try to strain your brain here. Let's go. I just got the right answer. One of the students said, what if we factor the expression? There it is. We just spent so much time talking about factoring things like what's highlighted in red. And the reason that we spent all that time doing so is so when we run into problems like we have here on number 6, and by the way, the answer, Sydney just gave us the answer, by the way, good job, Sydney, is to figure out how Sydney got that answer through a factoring possibility. So what we're going to do is we're going to factor this red expression. How are we going to do so? X table. Here we go. So this is like the ultimate problem because it involves factoring and the zero product property. It's everything combined into one hard problem. So the question now is, how do we fill out the X chart? We say, all right, first number times last number. 1 times negative 30. And 1 times negative 30 is negative 30. Let me write that a little bit smaller here. Negative 30. And then we want to find the factors of negative 30 that add up to what? Let me change my color here to green. The number in between. The first times the last, the factors add up to middle. What's that number in between? Well, if it's not visible, that number in between must be a 1. Cool. So we have 1x. So we then ask ourselves, all right, what are the factors of negative 30 that add up to 1? And we get our solutions, 6 and negative 5. Because 6 times negative 5 does give you negative 30, and 6 plus negative 5 gets you positive 1. Sweet, we have our values. So what we can do now is use our X chart to rewrite this problem. Here we go, ready? X squared and negative 30. Keeping in mind, y'all, that I left this middle blank. Why? Because I'm expanding this 1x into the numbers that we just got, a positive 6x and a negative 5x. Again, so flashing back to that logic of factoring. Now what we have here, after doing that, is the ability to group. So we're off and we're running. We look for a GCF. What can I take out of the first group here? They both have an x in it, so let's take it out. What do I have left on the inside when I take out the x? Well, a regular x, and when you take out the x from 6x, you're just left with a positive 6. We know the shortcut. We say, all right, well, when our first parenthesis is x plus 6, our second parenthesis has to be x plus 6. Now we can ask ourselves, what do you got to take out of negative 5x to make it a regular x? And what do you have to take out of negative 30 to make it positive 6? AKA, what do you got to divide those by? The negative 5. And here we go. We're almost done with the factoring. So this is a multi-step problem because we had to realize up front we can't combine like terms. So then we use the recommendation of factoring. First times last, factors add up to middle. Boom. Replace that middle term with the 6 and the negative 5. Factored by GCFs. And can someone tell me what we do from this step here to finish the factoring process? Yeah, great call, Francis. We combine the GCFs, the red things, to get x and a negative 5, aka x minus 5, and we multiply it by that common parentheses x plus 6. So you might be thinking to yourself, how in the world did Sydney get her answer of negative 6 and 5? Here's how. Once we've done this whole lengthy process, The hard part is done because now we can lean on our knowledge. Ready? I'm going to erase this in 1 second, but we can lean on our knowledge of the zero product property, which states that when you turn an equation into a multiplication problem that's equal to 0, all you got to do, if you turn it into a multiplication problem that's equal to 0, all you got to do is take those factors, the parentheses, and set them equal to 0. Well, guess what we just did in number 6? We turned an addition and subtraction problem of unlike terms into a multiplication problem by factoring it. That's what factoring does. It turns it into a multiplication problem. And now what we can do is use the zero product property and say, all right, take my factors, take my parentheses, and take each individual parenthesis and set it equal to 0. We block this out down here so we don't get distracted by number 8. Cool. Now all we got to do, and I'll write this one more time down here a little bit easier so I can work with it, is isolate x in each problem. Get rid of subtraction with addition, boom. We have one solution that x is equal to 5. We get rid of addition with subtraction, subtract 6 from both sides. We have one solution that x is equal to -6. And sure enough, how many answers did we get? 1, 2. What was the exponent on the original problem? 2. So the exponent tells you the number of possible solutions, and sure enough, we verified that by factoring, setting the factors equal to 0, zero product property, and then solving to get what Sydney wrote from the jump, -6 and 5. Now that's a super long problem, which is why I mentioned that number 6 is very hard, because what number 6 just required of us to do is it really required for us to do 2 things. Well, really 3 things. It required us to remember what it means to factor, and then it required us to use the zero product property, setting the factors equal to 0, and then it required us to solve for each factor individually. But once we get comfortable with the process of factoring, and that was why we spent the last 2 weeks doing these steps here that I'm kind of circling around. After that, it's really just applying that zero product property that we've been kind of working on. We introduced at the beginning of the year, and now we've revisited a couple times at the end of the year, kind of bookending the whole year. All right, there's number 6. We're going to try number 7. I'm not singing well either. Okay, number 7. Any thoughts? What can we do? It's not as easy as numbers 1 or 2. Why were numbers 1 and 2 so easy? Because they were already factored. All we got to do is set them equal to 0. Number 7. Any thoughts? Any thoughts? This one is actually easier to factor, but it just might be harder because it's a little bit harder to see the X chart in it. Yeah, Francis, P equals 7 is one of our answers. Francis has given us one answer right from the jump. Yep, P equals 7, great job. But I'm going to claim that there's 2 solutions. So Francis gave us half the answer. P equals 7 is 1. -7 is a good guess, but not -7. And here's why. Let's check it. If I was to take -7 and plug it in for P, here's what I would get. Ready? -7 plugged in for P, making all those P's -7s, okay? And I just did order of ops here. -7 times -7 is 49. -7 times -7 is 49. And 49 plus 49 doesn't equal 0. 49 plus 49 equals 98. So quick check says, -7 doesn't work, but I like the logic, Francis. +7, on the other hand, did work, and here's why. +7 squared is 49. A negative times a positive, -7 times +7 would make the second one into a -49. And sure enough, what is 49 minus 49? 0. So +7 checks out. So what did we do on number 6? What did we do on number 6 when we were dealing with a problem that had no like terms that couldn't be added, we did what? We factored. Whoa, sorry, my finger's going crazy all over the screen. We factored. So let's do that. When we have a problem like number 7 here now that we can't add together, we can't subtract because they're not like terms, we got to factor first. So how can we do that? Well, what is the whole goal in factoring? What do we always look for when we're factoring first? We might have gotten so caught up in the X tactic that we forget the whole point of factoring is doing these things here in red, and that's, we look for GCFs. And number 7 actually has a GCF right in front of you. Can anyone tell me what that GCF might be? There's 2 terms in here. Ready? Red term, blue term. What do the red and blue have in common? Yeah, Francis, good call, man. They both have a P. So like we did over here, when we were factoring individually these two groups, we do this whole X chart process so that way we could break something down and look at it into groups of 2. But look at number 7. We don't need to do that because do we already have a group of 2? Yeah. So basically what we're doing on number 7 is we're actually only doing part of the whole X chart tactic. We're saying, all right, the GCF is P. Let's take P out. And what happens when I take a P out of P squared? Well, P squared becomes P. And what happens when I take the P out of negative 7P? I'm just left with a negative 7. So in this process, on this problem, once we realize that, hey, these terms aren't like, we got to factor, we always try to factor by finding a GCF first. And in this case, that was available. The GCF was P. So what we've just done, y'all, is we have created a situation that allows us to solve for our problems. And the reason for this is because take a look, we now have a zero product property or a multiplication problem. We use different colors here, where we have something times something else. So we set the factors, the multiples, equal to 0 and solve. When we work with the orange one, we get Francis's answer. That P, now by itself, is equal to 0 plus 7 or 7. Francis is right. Great job, man. When I set the other factor, the GCF, the greatest common factor, equal to 0, this is my favorite type of problem right there because it's already equal to 0. So we have how many solutions? 1, 2. How many solutions did we expect to get? 2. And if I plugged them in, it would prove and check out because, ready? Let's just check this out real quick. P squared minus 7P is equal to 0. But what did I say P is equal to? 0. So let's make all of these P's 0. Ready? 0 squared minus 7 times 0. Well, what's 0 times 0? 0. And what is negative 7 or 7 times 0? 0. And does 0 minus 0 equal 0? Sure does. It checks out. So really what we're learning here today, or we might be seeing today for the first time, is that we can take things that would have been impossible to solve before a couple weeks ago, factor with our skills of finding GCFs or using the X chart, and then apply or use our zero product property to help us solve it. So let's do one more before we leave for today, okay? Number 16 is way too hard. We'll do that one. We'll do that one next week. Oh, shoot, we're running out of time. So how would I do number 12? Let's just start off. We'll try to do this one rapid fire here. Do I have like terms? Can I add these two things? Nah. Why? Because of that. The 7x has a squared, the 2x does not. So they're not like terms. So what do I got to do? Factor. What do I always look for when I'm factoring first? The GCF. I don't even need to try to group this because guess what? I only have two terms. It's already a little mini group in and of itself. So what's the GCF of this? I'm going to take out of both of those things. Yeah, great call. X. We could take an X out of both of them. Look, they both legitimately have an X in them. Boom, boom. So we take an X out, and what do I have left on the inside? Well, a 7X, and if you take the X away from 2X, you just have left with a 2. What is this whole thing still being equal to? That hasn't changed. 0. Now what do I have? I have a multiplication problem. Ready? Green times purple. Like a distributive property. Distributive property is always multiplication. So I take those multiplication, those factors, the green, I set it equal to 0. I love that one. It's already solved. And the purple, 7x plus 2, and I set it equal to 0. Zero product property right here, y'all. That's what the zero product property is, this step right here. Then all I do is subtract to get rid of addition. Boom. What am I going to do to get rid of this 7? Divide it, because it's being multiplied by 7, so I divide. And now do I have x isolated? No doubt. Do I have an answer? No doubt, number 2. 2 answers, because a power of 2 says we should have potentially 2 answers, and sure enough, we do have 2 answers by factoring and then setting the factors individually equal to 0 and solving. And then it's like the beginning of the year all over again, where we solve by using SATMEP, working backwards using opposites. So what we're going to do on Thursday, y'all, is we're going to come in, do a couple of problems from this lesson to warm up, and then move into lesson 18, which is really just the concepts that we saw in number 6 right from the get-go, where we can factor to make problems that are seemingly very difficult and very difficult to solve, impossible to solve maybe, but realize that they are possible through factoring and the use of the zero product property. So without any further ado, if you don't have any other questions, I look forward to seeing you on Thursday. If you do have any other questions, stick around and feel free to type them or unmute yourself and ask. Have a great day, everybody. I appreciate y'all.
Have a great day too.
Thank you. Thank you. All right, I'm going to stop recording, everybody.